That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you count, it's from 0 up to 9. So now, what happens when you want to make a 10? When you want to make a 10, you get a 1. From where? There, you get a 1. Then you borrow a 0 from there, then it will be 1 and 0, 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, until you reach 9. When you reach 9 there, what do? You were on 0, you move to the next number, then it becomes 2. So it will be 2 and 0, 2 and 1, 2 and 2, 2 and 3. So that's how the format goes. And this is what makes decimal. So, for instance, if we were to cut this into half, like that, and we said we use the same format, 0, 1, 2, 3, 4, 5. When you reach 5, what do? We go back this side and get the 1. So we say 1, 1 and 0, 1 and 2, 1 and 3. So it's going to move like this: 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5. When we reach the 5, because we've already arrived here, what do? We get the next 2 and bring it here, and we say 2 and 0. We go back where? There, and it becomes 2 and 0. 2 and 1, and the sequence continues like that. Now, what happens if we remove some of the numbers and we just leave these 2? How is that going to be? Okay, so this is going to be 0, 1. When we reach 1, where do we go? We go back that side, where? There, and then we start all over again. 0, 1. Then where do we go again? We go there, we come back this side, then it becomes again 0, 1. So all we'll be doing is we'll be moving with 0, 1. Just like the time we had from 0 to 9, we are using all the numbers there from 0 up to 9. And therefore, if we are to just start from 0 and 1, it's going to leave us with 0, 1, 0, 1, 0, 1. These are the 2 numbers that we're going to use, and these are what we call binary. So binary only has 2 numbers. So those 2 numbers are just zeros and 1. Now, please note, it is 0, 0, and 1. It is not like this. It's not 0 and 1. It's not right. 1 and 0. So you don't start with 1 and 0. It is actually 0 and 1. So you have the 0, which is first, and you have the 1, which is next first. Okay? So 2 numbers that binary uses. Okay? Now, the first thing we said was that bi means 2. The same way you have a decimal. Dec means 10. Bi means 2. So we'll be dealing with only 2 numbers. And what are those 2 numbers? Those 2 numbers are 0 and 1. So 0 and 1 are the only numbers that a computer understands. Only understands zeros, and it only understands ones. 2 numbers. So you might write something or type in something there. The computer in its brain just thinks of zeros and 1, 0 and 1. So all the computer is going to be doing is computing what you're doing into 0 and 1. You are typing, Jelita is a girl. In the brain of the computer, it is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So it's just doing 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. And yet you type Jelita is a girl. How binary works. We say binary means 2. And I will introduce 2 terms now. Base and radix. Those of you who are writing, write these words down. Base and radix. Base. We've said binary uses 2. Okay, so binary is given two things in hand like this, and then it sits. So where it is seated there, the base, where it is seated, how many things is it holding inside there? So when it sits like this, how many things have you put in its hand? You only put 2. So if you put binary in my hands like this, which means that where I'm sitting on the base, I am sitting on only 2 things. So binary is base 2. Binary is base 2. And it's the same thing with radix. Radix and binary are the same. I'll explain what base is and what binary is in the next sessions later on. I just want you to know that binary is in base 2. Just like we have decimal is in base 10. Binary is in base 2. Okay. This is the time you drink a little bit of water, not too much. Don't overload your brain. Base 2. If you get octo and you put octo, you remember I said octo has got how many? 8, right? So you put 8 of them here. Base, where is it sitting? On base 8. So octo is base 8. The last one is hexadecimal, is 16. So the same principle, you put 16 of them and it is sitting on base what? 16. Okay. Now let's do some simple calculation and find out how the brain of a computer actually works. So when we enter the brain of a computer, now just a minute, take another sip of water because you will need that water for this part. Okay, you have binary. I said it is 0 and 1. So in simple terms, because it is 0 and 1, if we were to ask ourselves, what is 1, 2, 3, 4, 5? Because what we said was, in binary, what I said, the brain of a computer only thinks in zeros and ones. 0, 1, 0, 1, 0, 1, 0, 1. That's all. Okay? So, simple. If you type a letter A, the computer is going to convert this A into zeros and ones. Zeros and ones. That's it. If you write down a 1 or type a 1 on the computer is going to convert this 1 into zeros and 1, 0 and 1. Now, what is 1 in binary? This is where I'm going to start from. Okay? 0 and 1 is simply 1. That's simple. 0 and 1 is simply 1. How do we know it's 1? So that's the way the computer works. So now we are trying to convert. This is binary and this is decimal. So now we're asking ourselves, when a computer which thinks in zeros and ones, zeros and ones, zeros and ones, thinks in zeros and ones, and then on the laptop there or your computer, you type 1. So the computer is going to say 0, 1. So you just type 1, just the number 1. Even on your phone there, you type 1, just 1, 1. Then the computer will convert that into 0 and 1. Next, we just do numbers from 1 up to 8. The rest you do on your own. So what happens here? Imagine you are seated. There are 2 lights. I've got two markers here. I don't know if you can see them. Okay, we got black and red. Okay, so red is this one. Red is going to symbolize, let me do this. Red is going to symbolize, let me shoot them like this. So this is 0. No. This is 0 and this is 1. Am I correct? Yes, I'm correct. So we have them like this. So you have your 0 and your 1. So what happens? This is going to be off because it is red. When it's red, you stop. When it's black, which means it's on. So this is off and this is on. Okay. So these two numbers here, 0 and 1. Remember when we are moving, when we're looking at decimals, we're saying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. By the time we reach 10, we just borrow where there. We go and borrow the 1. Borrow the 1 and lift it and take it to, let me just write it there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you want to make 10, you get this one. Lift it, don't drop it to make a mistake. Make sure it touches the end. There. Okay. So you have your 1. If you want to make 10, you get the 0 there. Nicely, don't drop it, put it there. It becomes 0. So this becomes your 10. Simple mathematics. Here, what happens? This is 1 and that is 0. So if you want to make the next value, this number is supposed to go that side, where? That side. Because here this one is on and this one is off. So that is off. This is on. So it's only two numbers, off and on. So now you want to make 10. So you get this one, you put this side, and then slowly you get that 0, don't drop it, bring it this side. It becomes what? So that one becomes your 2. Okay? And then you go back. You go back where? There. You start from the beginning. So this is 0. Now, 0 is off. You need it to be on. So before you move, you need that value to be on. So because this is a 0, what you're going to do is to switch it on. You switch it on, so that is 1, and this one will remain on. So 3 is 1 and 1. If you're confused, just take a little bit of water. So we are on 1 and 1. So what happens if you want to make a 4? Now let me wrap everything so that you're not confused when the 4 comes. Each time I'm wrapping, sip a little bit of water. Okay. All right. Now, we said 0, 1 is 1, 1, 1 is 2. Was it? No. 1, 0 is 2, 1, 1 is 3. Now we are going to make a 4. Okay? For the 4, here you have 1, and there you have 1. So here both lights are on. So it's like I have two black markers. Both lights are on. What do I do? Now I need this light to be off. So the first one there, I'll switch it off. And then I'll go to the next one. The first one is off. I'll find that the next one is still off. But I need it because every light needs to change at first. So here it was on, we now switch it off. So we switch it off again. So that's going to be 0. And then you take this one to the next level.
Oh yeah, the boy.
Pause the volumes on your phones. Pause the volumes on your phones. Kindly pause the volumes on your phone. Pause the volumes on your phone. So 4 is 100. Okay, we'll go through this in another. You remember? Okay. Now, how do we make 5? Simple. We go back where? Pause the volumes on your phones.
Do something about
Pause
it.
the volumes on your phones.
I mean, Krasi, but they move for they can able to hear his cries.
Pause the volumes on your phones. I don't know how you do that, but there's a blue button there. Pause it. And who's that? who's that making noise? Okay, so we're on 100 there. We're now going to make 5. Okay, so for a 5, we go back where? There you have your 0. So this is off, on. So this is off. We need it to be on. So this is going to be on. But you don't temper with that one because it's off. So you leave it off. And there you leave it what? On. Because it's ready. So these two are already in order. So that is 5. Now what happens on your 6? I don't know. You've got your 6 there. You go back where? There. You find that it is on, but you need it to be off. So this one is off now. It was on. So you take this one, that side, so it's going to be 1. But since this one is on already, and then you've already changed the one before it, no problem. So you leave it like that. So that becomes 6. 7. You go back where? There. The beginning.
Yeah.
This is off. So what do? You switch it on. Since you've already switched this one on, no problem. These ones just remain like this. And that is your set goal. Yes. There we are on 7. One more, 8. Can someone try to guess what you're going to do on 8? Write on your pieces of papers there. This is on. You need it to be off. So you switch it off, it's going to be 0. Take that one left side. You find that where you're taking the one, it's already on. You switch it off. Then here, what happens? You take that one that side. You put this one here. You find it is already on. You switch it off. And then you take that one where? There. Then you have your 8 there. The rest from 8 up to 15, you can do that. That is your homework. Immediately after the session, you can do this, and within 10 minutes, I'll give you the number. You just send the answers to your WhatsApp. Okay? If you've not gotten this clearly, I'll explain it in the next session. I'm just giving you the basics so that you understand binary in different perspectives. And remember, binary is the only language the computer understands. Binary means 2. Bi means 2. Bi is under number system, and the number system has got 3 parts to it. There is binary, there is octo, and there is hexadecimal. Bi 2. hexadecimal. Binary is 2. It is of the radix 2 of base 2. And then you have octal, that is base 8, like this. 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. And then you have hexadecimal, which is simple mathematics. Okay. Next part here, we are now going to look at a different perspective for this. I just want to show you a bit of how the computer operates. We've looked at numbers, we've looked at decimals. Now let's look at numbers. Letters. When you type in the letter A in your computer, how does the computer think? It thinks in zeros and ones. Simple. Even if you didn't know what A was, just know that it thinks in zeros and ones. 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 0. That's the way the computer thinks, in zeros and ones. Okay? Now, because it thinks in zeros and ones, they put up a form in which we are supposed to calculate these zeros and ones. Is what is called ASCII. ASCII is a conversion. This is what how can I put it? This is what they decided to use as a chart. So this is like a board where you have numbers that are relating to the way the computer thinks. So A is 65. B is 62. C is 67. And then you go on like that. Now, you type in A, the computer converts it to 65. But now, what is 65 in binary? Okay. So this will tackle in the next session. So you can write this down. I'm going to wrap it very shortly. ASCII. This is a form in which conversions are done. ASCII simply means American Standard Code Information Interchange. Americano, standard, a way, a form in which things are done. Code, this is a code, meaning that A is equal to 65. And 65 here in binary is going to be 0, 1, 1, 1, 0, 0, 0, 1. We'll find out how to do that in the next session. Okay. I only have 10 minutes. So I'll just run through the last part. Okay. Now, do you remember when we started, I said binary has got a format, okay, just like any other format. Let me give you an example of certain formats that are used in measurements, for instance. If you have to measure things, you've got mg. Mg is milligram. Right, bigger. I don't know if you're seeing them. Mg is milligram. Then you have kg, kilogram. Then you have a ton. I think. I hope I've not skipped anything here. So you have like 10 kg, 100 kg, and you've got things in that form. And then when you reach 1,000 kgs, you've got 1 ton. So 1,000 of these makes 1 ton, and I think 1,000 milligrams also makes 1,000. 1,000 milligrams also makes 1 kg there. Also makes 1 kg, and then 1,000 of these kgs makes 1 ton. So you are able to follow. If you've got water, you've got the what do you call it? If it is water here, it is liters. So from a liter, you know that, okay, this is 1.5 liter. If it goes beyond the liter, it also has different types of measurements. Okay. So because you are able to measure things in this form, also in computer language, you are also able to measure things. The brain of a computer is also able to measure. Now, let me give you an example. If you have a phone, some of you like boasting, I've got a phone, got a phone, and my phone is 1 GB RAM, 1 GB RAM. So what does 1 GB mean? You're talking about 1 GB RAM. So you're saying my phone is 1 GB RAM. We'll look at these in detail the next session. Okay, what if it's below a GB? What is it? My phone has got 1 GB RAM. What if it's below a GB? What does it become? It becomes an MB. So you're saying my phone has got 500 MB. You're talking about an MB. But when an MB reaches 1000, then it becomes a GB. All this is related to binary. Now let me show you how. We have 5 minutes. So binary means 2. You're talking about a binary, it means 2. And when a computer calculates, okay, this is the base. I'm talking about the base now. So when a computer calculates its frequency, the way it calculates, for you to reach on MB or for you to reach on GB, it calculates this in 2 ways, or one of the 2. It can either multiply by 2 or add by itself. If you're not clear, drink some water. Can either multiply by 2 or add by itself. So 2 by 2 is 4. 2 plus 2 is 4. Okay, so now when you reach on 4, what do? You multiply by 2 again or add by itself. So 4 times 2 is what? 8. So 4 plus 4 is equal to 8. The same thing. When you reach on 8, what happens? Do the same thing. So there it will be 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. You've heard of computers that have 64 processor is 64 or 32. This is how they make it. From 64, you've got 128. 128, you've got 256. 256 times 2 is 512. 512 times 2 is 1. There it is 4. There it is 2. There it is 0. Like that. So when you say you have 1 GB of RAM,
Sir?